this is Janet and Rabia.
Welcome to Everest Physics Academy.
In this video, we are going to define the displacement vector. Compare the magnitude of the displacement vector to the actual traveled distance. Write the characteristics of the displacement vector. Solve an exercise about displacement vector.
The displacement vector of a moving object between two positions is a vector that joins the initial and the final positions of this object. To understand the displacement vector, observe this video. This car moves from position A to position B. Then, its displacement vector between A and B is given by delta R, which is equal to the vector AB.
Consider a particle moving along a curved path. Here is the position vector of the particle at an instant t1, and here is the position vector of the particle at an instant t2. Delta R is the displacement vector. As we have seen in the previous slide, the displacement vector delta R of a moving particle between two instants is a vector that joins the positions of the particle at these two instants. Now look at the figure carefully. What is the relation between R1, R2, and delta R? As you see, R2 is the resultant vector of R1 and delta R. Therefore, R1 plus delta R is equal to R2. This is going to be delta R is equal to R2 minus R1, which is equal to AB, the vector joining the initial and the final positions. This is the expression of the displacement vector.
The figure shows the path followed by a mouse between A and B in order to catch a piece of cheese. The actual distance or the travel distance between A and B is denoted by D, and the displacement vector of this motion is delta R. So, the magnitude of delta R represents the shortest distance between A and B. Observe the figure. The shortest distance between A and B is not equal to the actual distance covered during this motion. So, on a curvilinear motion, the magnitude of the displacement vector is not equal to the actual distance AB or D. On the second figure, this plane moves in one direction from A to B. The displacement vector of this motion is delta R, and the magnitude of delta R is equal to the actual distance D. So, in a rectilinear motion in one direction, the magnitude of the displacement vector is equal to the actual distance covered during this motion.
Let's move to the characteristics of the displacement vector delta R between two instants t1 and t2. In this figure, Tom leaves his house at point A at the instant t1 and goes to the factory at point B where he works. Tom moves on a curved path. Look at the yellow vector. The yellow vector is his displacement vector between A and B, and the origin of this vector is the initial position of Tom at the instant t1. The line of action is the line joining the initial and the final positions of Tom at t1 and t2. The direction, as you see, is from the initial position to the final position, and the magnitude of the displacement vector is equal to the length of this vector, which is equal in the figure to the distance AB.
Focus, please. This is important.
Let's solve an application. The position vector of a moving particle m in xy plane is given by t minus 4i plus t squared j in SI. This animation shows the trajectory of m during the first 6 seconds. Part 1. Write the expression of the position vector at time 0 and at time 2 seconds. R of 0, replace t equals 0 in the expression of r. So, R of 0 equal 0 minus 4i plus 0 squared j, then R of 0 equal minus 4i in meters. Similarly, replace t equal 2 seconds in the expression of r, then R of 2 equal 2 minus 4i plus 2 squared j, Therefore, r of 2 equal minus 2i plus 4j in meters.
Let's move to part 2. Determine the displacement vector and its magnitude between time 0 and time 2 seconds. We have the initial position vector and the position vector at time 2 seconds. You know that the displacement vector is equal to the final position vector minus the initial position vector. So replace the position vector at time 2 seconds by minus 2i plus 4j and the initial position vector by minus 4i. You get this equation. This is going to be delta r equals 2i plus 4j. The magnitude of the displacement vector is expressed in meters. Now we want to calculate the magnitude of delta r. This magnitude is given by this expression, the square root of the x component squared plus the y component squared. This is going to be the magnitude of delta r equals 4.5 meters.
Part 3. Is the magnitude of this displacement vector equal to the distance d traveled by the particle between time 0 and time 2 seconds? To answer this question, we have to determine the shape of the trajectory. If the shape of this trajectory is a straight line and the motion has one direction, so the magnitude of this vector is equal to the distance d. And if the shape of this trajectory is a curve, so the magnitude of this vector is not equal to the distance d. Now let's determine the equation of the trajectory. The parametric equations are given by x equal t minus 4 and y equal t squared. X equal t minus 4, then t equal x plus 4. Now substitute t equal x plus 4 in the expression of y. Then y becomes x plus 4 squared. Hence, y equal x squared plus 8x plus 16. Since y has the form of ax squared plus bx plus c, where a and b and c are constant, therefore the shape of this trajectory is a parabola or has a curved shape. Therefore, the magnitude of the displacement vector is not equal to the actual distance d between time 0 and time 2 seconds. Thank you for watching. If you like this video,
Subscribe to the channel, hit the like button and share.